Okay, we're going to solve this question using integration by parts. Now, for this particular question, I'm going to set it up letting u equal x, which means dv is going to equal the sine of x dx. Now, I will take the derivative of u, giving me du equals dx. I will take the antiderivative of dv, giving me v equals the negative cosine of x. Now, according to my integration by parts, we have the property that the integral of u dv equals u times v minus the integral v du. So all I have to do now is plug everything into its proper place. So my antiderivative of x sine of x dx is going to equal u times v. So u times v is, let's see, a positive times a negative is going to be negative, so it's going to be negative x cosine of x minus v. So since v is negative and I'm subtracting a negative cosine of x, that'll become a positive on the outside, cosine of x times du, which is dx. So I can continue on here. I have negative x cosine of x. The antiderivative of cosine is sine, and that should be my final answer. Now, of course, you can check your work by taking the derivative of the left side and making sure that it gives you the actual right side, so we can check our work. Again, this is my final answer. So just checking the work, I'm going to take the derivative with respect of x, and I'll leave it written as it is, of negative x cosine of x plus sine of x. And again, I'm just checking my work at this point. So using the product rule, this is going to equal the derivative of the first times the second plus the first times the derivative of the second, and the derivative of cosine is negative sine. And now we're back to this part, plus the derivative of the sine of x, which is cosine of x. Okay, so I end up with negative cosine of x. A double negative here is a positive x sine of x plus cosine of x, and it's clear that this negative cosine and this positive cosine will reduce out, giving me my final answer, which is, I actually don't need the positive, final answer, x sine of x, and that should have been what I was originally trying to take the antiderivative of, so my work checks out.